Hello, my name is Ryan Draper. I'm a product manager at Microsoft.
My name is Austin Ma. I'm a product manager at Microsoft.
Here at Microsoft Azure, we know how important PostgreSQL is for mission-critical apps across every industry. The big question for developers is whether you stay managed or operate Postgres yourself. Of course, there's Azure Database for PostgreSQL, a fully managed service that handles patching, backups, and high availability. And then there's the option to self-host Postgres on Azure Kubernetes Service, or AKS, for teams that require extra control. So let's explore how Azure and our infrastructure can help you successfully host Postgres with Kubernetes. Here's what we'll cover in this video. First, why teams choose AKS and CloudNativePG. Then, building blocks of resilient Postgres on Kubernetes. And finally, how to operate, monitor, and recover the cluster. Whether you need custom extensions, deeper tuning, or tight integration with your Kubernetes toolchain, self-hosting gives you that control. You pick the exact Postgres image, plug it into your CI/CD pipeline, and scale your performance as your workload grows. You can also decide on VM sizes, storage classes, and replica counts. Let's look at what makes AKS such a strong fit for self-hosting Postgres. It all starts with the virtual machines. Your node pool choices help shape the performance of the workload. General-purpose D-series machines can handle most workloads. Memory-optimized E-series help with heavy caching. Storage-optimized families like LSV3 or LSV4 bring local NVMe, which cuts latency for write-heavy clusters. Azure Boost removes extra virtualization overhead by offloading networking and storage to the dedicated hardware. On supported VM types, that means steadier low latency, which matters for features like fsync and transaction commits. AKS keeps the Kubernetes control plane managed and patched. You shape the worker node pools, add auto-scaling, and plug into Azure Identity, networking, and observability services. It's a balance. Kubernetes orchestrates the pods, while Azure handles the node lifecycle, identity, and networking.
Our reference architecture uses a multi-zone AKS cluster with 3 Postgres pods managed by CloudNativePG, a popular open-source Postgres operator. We designate one pod as the primary and use the 2 others as synchronous replicas. An Azure load balancer sits in front of the read and write traffic. Azure Managed Prometheus and Grafana provide metrics dashboards. For backups, the operator streams data to Azure Blob Storage using workload identities, so there are no static credentials. Now let's talk about storage. Storage can have a big impact on performance. Premium SSD and Premium SSD v2 disks both deliver high performance and low latency. Premium SSD v2 provides the most flexibility and value, allowing you to independently configure capacity, IOPS, and throughput, making it ideal for workloads that need a strong balance of price and performance. Azure Container Storage with local NVMe drives reaches sub-millisecond latency for write-heavy or the most I/O-intensive scenarios. Just remember that local NVMe is tied to the VM. We recommend having a backup system to Azure Blob Storage so a node pool recycle doesn't cost you data. CloudNativePG pairs with Barman to send wall archives and snapshots to blob storage over that managed identity. Remember, if you plan to rely on NVMe for ultra-low latency, make sure the VM family ships with local NVMe devices, such as L-series machines. CloudNativePG is what keeps day-to-day operations manageable. We install the operator in its own namespace. From there, a single custom resource spells out replica counts, backup targets, TLS, and maintenance windows. The operator handles rolling failovers, keeps replicas spread across zones, and manages connections so the cluster writes out node drains.
After the cluster is live, day 2 operations start with checking the status of the database. That quick check shows which pod is primary, where the replicas sit, and the current log sequence numbers. Because we schedule across multiple zones, the database keeps running even if the zone goes dark. When you need more detail, CNPG also lets you pull a full snapshot of the cluster's health. It calls out replication roles, storage assignments, and the conditions the operator is tracking. Use it when something feels off and you want a structured report before diving into logs. If you're investigating storage or throughput, you can stream the Postgres logs from whichever pod currently owns the primary role, so you can watch checkpoint activity, auto vacuum behavior, or slow queries without guessing which pod to connect to. For replica health, we can surface your existing base backups and Vault archives. You can confirm when the last backup ran, where it landed in blob storage, and whether the retention policy is being enforced. For disaster recovery, Barman takes care of the scheduled snapshots and Vault archiving straight into Azure Blob Storage. One command triggers an on-demand backup, and each run lands with a clean timestamp. Workload identity supplies the credentials, so there are no secrets to rotate. And we're only just scratching the surface. The Postgres community ecosystem has incredible depth, and with the versatility and speed that Azure provides, you can craft, build, monitor, and secure deployment in more ways than ever before. At Azure, we want to give developers as much flexibility as possible. Self-hosting Postgres on AKS delivers the highest degree of flexibility using powerful operator-driven automation and the incredible cost efficiency that comes with Azure infrastructure. When you're ready to dive deeper, head to our Postgres documentation and start your self-hosting journey. That concludes our session on running PostgreSQL on Azure. Thank you for your valuable time.
We can't wait to see what you build.